Hey guys, we know that when it comes to evaluating double iterated integral, we usually follow this order to evaluate the inside integral first and then the outside afterward. But at the first glance of this question, we have the function being integrated being e raised to the power y squared, which is something called the Gaussian function, whose antiderivative cannot be expressed as an elementary function. And therefore, using any type of techniques that we learn in single variable calculus, such as integration by parts or U substitution to try to find the antiderivative for the inside function, just simply won't work. And therefore, we need another method to find this integral, which is called switching the order of the integration. As we know, when it comes to double integrals, there is something called the region of the integral. And the process of the integration is just essentially using strips to fill out the region. Okay, you can use horizontal strips or vertical strips, and that will determine the order of the integration. Okay, so let's find the region first, and then we're gonna change the order by changing the strips. Okay, we're gonna have the y-axis and x-axis. And then the original expression says that is with respect to y for the inside. So that being said, we're gonna have vertical strips. Okay, vertical strips whose tail sitting on the line y equal to 1 over 2x, which is like that, y equal to 1 over 2x. And the head of the vertical strips is sitting on the line y equal to 1. Okay, so we have y equal to 1, like that. This y equal to 1. So we're gonna have a bunch of this kind of vertical strips like that of flexible length. Okay, so it's gonna range from, right, you can take a look at the bounds of the outside integral from 0 to 2. Okay, x equal to 0, that's essentially the y-axis, and then x equal to 2 is somewhere, we need to find this point. The point of the intersection is 2, 1. Okay, so essentially like this. So imagine you're gonna have a bunch of this kind of flexible strips kind of swiping this way to fill out the region. And therefore, we now have what the region looks like. The region is simply this triangle here. Okay, so by saying changing the order of the integral, we mean that we're gonna use a different strips to fill out the region. Okay, so instead of using vertical strips, we can take horizontal strips. So imagine you're gonna have a bunch of horizontal strips like this. Okay, to sort of fill out the region. And then if we take a look at the upper bound of the horizontal strips, those are sitting on the line y equal to 1 over 2x. Oh, sorry, I'm missing an x here. Y equal to 1 over 2x. So we solve for the x, that is x equal to 2y. And then if we take a look at the lower bound of the horizontal strip, that is sitting on the y-axis, which is x equal to 0. Okay, so now we can express this in this way. Lower bound being 0, upper bound being 2y. And same function, e raised to y squared, because we're taking horizontal strip, so the inside integral is with respect to x now. Okay, and then the process of filling out the region using the horizontal strips is like the strip moves from the bottom, which is y equal to 0, all the way to this line, which is y equal to 1. So that gives us the bounds for the outside integral, which is with respect to y, then from 0 to 1. Okay, so now we have successfully switched the order of the integration. So next, let's complete the calculation since it's not very complicated. Okay, so we're gonna evaluate this one that is with respect to x, this is gonna be treated as a constant. So we're gonna have its antiderivative being x times e raised to right this way, ey squared times x, okay, with upper bound x equal to 2y and then lower bound x equal to 0, okay, dy. And if we plug in, we have 0 for this one and then 2y for this one, so that's gonna take us to ey squared 2y dy. And the rest of them is just simply calculation, okay, u substitution. And for me, I prefer to write it this way to put this into the differential sign. So that can be written as from 0 to 1 ey squared dy squared. Okay, so we can have eu du, whose antiderivative is just simply eu, which is ey squared, and then upper bound, lower bound, okay, which is going to take us to e minus 1. Okay, so that is how we do this question.